All right, so CSE 222, Intro to Data Structures in C. I'm going to go through some of the syllabi and additional course info and so on. I'm going to do this fairly quickly. But if there's any questions or anything you want clarification on, like I say, either ask or send me an email or catch me in office hours. So data structures, we're going to talk about what data structures are today, but it's basically advanced programming. Okay, data structures are one of the most important concepts in programming. One of the things that makes good programmers great. So most everybody in here has done 224, okay, which presumably means that you've got a good level of comfort with programming and with C in particular, and hopefully with a Unix environment. Okay, more about that in a few minutes. There's an open source textbook that I've posted a link to here. Feel free to download it and keep it as a reference. I don't suggest printing it out. I don't suggest reading it cover to cover. Okay, it's very thick, it's very dense, but it covers a lot of what we're going to talk about. It covers a lot that we won't get into. It's also a decent reference for a lot of what we do in 223. And I think it's pretty well written text. So that's the official course text. It's free. And then, you know, any reference on C and Linux will be useful as well. You can read the topics to be covered so that you might recognize them when we get to them, but they won't mean a whole lot right now because we haven't really talked about these things yet. But there's lots of material we're going to cover. Course policies is the same boilerplate in every course that you've taken with me, okay? So I'll let you read those. Support services, I'll let you read this on your own, but again, if you feel like you would benefit from some sort of accommodation, having a note taker in class, having a seat in the front of the room that you can sit in, having extended testing time or testing in a low distraction environment, anything like that, come and talk to me, talk to the DSS office, send an email, call, visit, something, okay, and we can work on getting that set up. Okay, again, the goal is to make sure that you have the optimal conditions under which you can learn this material and demonstrate your understanding of it and be successful. Okay, so lots of support services available. College-wide policies, so I've read this to you before, and this is the same in every class, but basically it's Clark's non-discrimination policy is something we take seriously, okay? So if anything is going on that is interfering with your ability to come to class, focus in class, learn the material, demonstrate your understanding of the material, etc., right? Say something, come and talk to me, talk to somebody else, and we can go from there. Okay, basically treat people with respect. We want to have an equitable situation where everybody basically has similar opportunity to be successful. Class cancellations, so we will talk more about this on Friday if necessary, but as you probably heard, there's a good chance there's going to be a teacher strike next week. Okay, a lot can happen between now and then, so I'm not going to spend time speculating because hopefully this will get resolved before Friday. But if Friday comes around and it looks like this is going to happen, we'll talk Friday about what that means for the course. Basically, the course will be put on pause. Okay, and so things that would be due on Monday, due dates will get shifted out. Any time that's missed will presumably be made up, although I haven't heard details of how. But, you know, forefront on all sides of this is concern for the students, right? And we want to make sure that you know, you get out of your classes what you need to get out of your classes. So that's going to be central to whatever happens and however this plays out. So we'll talk about it in details on Friday if it still looks like it's going to happen. But we'll find a way to make it work regardless. I don't think we're going to have any snow days this year, but you never know. But you can check the website, and the website also has information about negotiations. All right, so the additional course policies is the one that takes precedence over the syllabus, so let's talk about this one a little more carefully. So, so my name's Nick. I'm your teacher. Class meets Monday through Friday, either at 10 o'clock or 11 o'clock. Okay, in here. Thank you. And if you came in late, just go ahead and add your name on here before you leave. So 10 o'clock or 11 o'clock. The 10 o'clock section has a number of empty seats right now. The 11 o'clock section has a few empty seats. You're free to move from one section to the other, okay, whichever one you signed up for. If you feel like you want to come in at the 10 o'clock one tomorrow, just show up at the 10 o'clock one. You don't need to tell me and ask permission or anything like that. The two sections will be kept in sync as much as possible. We'll cover the same things each day and so on, so you have some flexibility there. My office hours are posted on engrcs.com, basically Mondays from 8 to 9, Tuesdays from 7:30 to 9, Monday, Wednesday, Friday from 12 to 12:30, and then Friday afternoons at 2. So I've tried to space these out. There's morning, afternoon, later afternoon throughout the week. Okay, so hopefully there's times in there that work for each of you. And the schedule is also on my door, so or you can just ask me. So my office is 115. It's on the other side of the collaboratorium, next to Izad's office. My email, nmacias@clark.edu. That's the way to reach me. Okay, I'm not going to respond to Canvas emails this quarter because Canvas email has been kind of hit and miss. So please send me email to my nmacias@clark.edu if you need to reach me. All right, grading for the course. 5 programming assignments, total of 20% of your grade. And those will be roughly 2-week assignments. One-day programs, which we'll talk about in a little bit, 15% total. There's a number of online quizzes posted on Canvas. There's several of those. That's a total of 10% for those quizzes. Midterm is 20, final exam is 25, and then service learning project is 10. So a variety of ways to get points.
Are there no SLP assignments this quarter?
SLP, 10%.
Oh.
Yeah. But there's no homework per se. And we'll talk about the SLP in a minute too. Okay, keys to success. You've heard me say some of this before. Let me just run through this fairly quickly. So the course assumes that you're fairly comfortable in C programming, you're fairly comfortable with algorithms, with taking a problem, breaking it into an algorithm, breaking those into steps and so on. To the degree that that may not be where you feel you are right now, you're going to want to spend some extra time in the beginning of the course coming up to speed. Okay. The reason being that we're going to be using C to learn new concepts. Okay. And if you're struggling with C syntax, if you're struggling with how to compile a C programming, you're fighting multiple battles. Right? We want to be able to use C as a tool to help us understand, so we can write an algorithm in C and you can look at that and you can use that to help understand what the algorithm is doing. Okay, we're going to be developing data structures from the ground up using C, and we're going to be learning more advanced C concepts like doing memory allocation, working a lot more with pointers and things like that. So the more fundamental things like syntax and looping and so on, you really want to be pretty solid with those. Okay. And if you got worries about that, talk to me as soon as possible. Come to every class. I'm not grading based on attendance, okay, but you want to be here for every class. And you want to try to be an active participant in class. You want to spend your class time thinking about what we're discussing and asking questions about it if there's questions that arise. What you don't want to do is just write down everything that I say and then go home and look at it and realize that you don't understand half of what we went over, right? Because then, you know, we're not in class anymore, and the next time we're in class, we're going to be talking about new stuff, right? If we're talking about something today and it's not clear what I'm saying, right, that's the time to say, I don't understand what you're talking about, right? That's hard to do sometimes, but as far as I know, nobody has ever laughed at anybody for asking a question in any of my classes, right? I've certainly never laughed at anybody. And guaranteed if you're confused about something that we're discussing up here, other people are confused as well, right? A lot of us suffer from the illusion that like we're the only one who's confused, or everybody else gets this, or everybody else is faster at this, or everybody else has a lot more experience with this, and it's really not true, right? The people for whom this comes very naturally and who feel very confident about this, they're the exception. But a lot of us are good at pretending, right? Or we're good at not asking questions, which makes it seem like we understand this. So it takes practice to figure out that you can ask questions, but it's a really, really good skill to develop, and it will help you a lot down the road. So try to spend your class time thinking about what we're actually discussing, and do I understand this? Why do you have to do that? What if I did this other thing, right? Those are great things to ask during class, and it makes the class more interesting. So try to avoid electronic devices unless you're one of the rare cases where you're actually more efficient with a laptop than with pencil and paper. It's very rare, okay? Laptops are really good at demanding our attention. Pencil and paper usually don't. Maybe your pencil needs to be sharpened every hour, but by and large, you take your pencil and you write on paper, and it does what you ask the pencil to do. Computers don't really work that way. You start typing, and it's like, would you like to update, blah, 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 now you got to deal with all that. Similarly, try to avoid distractions and tangents. If I talk about something that seems intriguing, just write yourself a little note and say, go back and look up such and such, or ask about this thing, But don't go off on a Wikipedia tangent and start looking into, Big Indian versus Little Indian and the history of computing, right? It's an interesting topic, and there's a big rabbit hole you can go down with that, right? But you don't want to do that during class when we're talking about heaps, right? Because then you get your ODP, and it's trying to work with a heap, and you're like, what's a heap? So make yourself notes for things you want to go back and look at later. All right, do your own work. I can't emphasize this one enough. Your goal is to figure out what you don't understand and then get to where you understand it, right? And that means making mistakes. It means writing code that does not work. It means struggling, right? And you got to do that. That's the only way you're going to get better at this stuff. If you can't get your code to work and somebody helps you, they're getting better at coding, but you're probably not. Okay? On the other side, if somebody comes to you and they're struggling, right, you can help them with general information. Don't ever show them your code. Okay? It's not going to help them, and there's a good chance it's going to hurt you. I've had cases where code was turned in by two students that was identical. And, in a university setting, that's at least an automatic F. At worst, it's dismissal from the program for both parties. And it may be that one student, was struggling and came over to their friend and said, I don't know how to do this. Can I see your code? And the person showed their code, and they took a picture on their phone, and then they typed it in. I've had this happen. And when it gets to the teacher, all you know is there's two assignments with the same code, right? Different spacing and indenting and a few typos, but it's the same code. And all you can say is, both get a 0. And that's a drag, especially if you spend a lot of time getting your code to work and you're just trying to help out a friend by letting them see what your solution was. So be really careful about this, okay? It robs you of the opportunity to learn, it robs somebody else of the opportunity to learn, and it can get you kicked out of school. And that's not a fun situation to deal with. Just being accused is not a fun situation to deal with. I've had friends who have gone through this, and it's a major disruption. And once you're accused, now the burden is on you to clear that up, and it's not something you want to deal with. All right. Break problems into subtasks. Our programs in here are going to be bigger than they were in 224. They're going to have more parts and pieces, and it's going to be even more important that you A, break your program into smaller pieces, and B, you get good at testing those pieces by themselves. Okay, so writing test code. You've got to write a program that's going to prompt the user for things, get input from them, and then decide which of 6 things to do based on that input. And then actually does one of those 6 things, which will involve some kind of data structure that we learn about, a linked list or a tree or whatever, right? There's lots of pieces there. There's the main loop that keeps prompting and inputting. There's the thing that's parsing the input and deciding what to do. There's the error handling if they put in something that doesn't make sense. And then there's the actual things that the program's supposed to do, create a linked list, add something to it, and so on and so forth, right? Lots of different pieces to that. If you can develop those one at a time and thoroughly test each piece, right, then you don't have to face this problem of, here's a 500-line program I'm supposed to write. Where do I start? Well, start with a piece that you know how to do. Get it to work. Now you've made some progress, right? So we'll keep developing this idea of modularizing code, developing it in pieces, testing it as we go, and then putting these pieces together. Work in Linux. Stay on the command line. Okay, don't use Eclipse, don't use an IDE, don't use Visual Studio, code blocks, those kinds of things. Stick with the command line. Okay, it will help you be more efficient, right? Because the less that you have to point and click, the more efficient you're going to be. It will give you skills that will work in whatever environment you find yourself in. You might be using Eclipse, you get to a job and they don't use Eclipse, right? If you learn the command line, you can always move from there to something else. And it gives you free learning, right? If you write integer main, parentheses, int argc, comma, char, star, argv, close paren, opening curly bracket, 10,000 times, you're never going to have to think about how do I write a main program, right? If you write gcc-o main.c-lm, you're never going to have to think about how do I compile my program and link the math library in, because you're going to have done it a billion times, right? And there were people at the end of 224 who did not know how to compile a C program, or don't know how to write a main function. And you get these things for free, right, just by doing it repetitively, and you get really fast at it. So stick with the command line as much as possible, and avoid IDEs. All right, additional policies. Please come to every class. If you don't get here in the beginning of class, make sure you at least watch the beginning of the video to see what you missed, because sometimes I'll make announcements and so on. Exams, as usual, closed book, open note, 4 double-sided pages of notes allowed. That should be plenty for this course. ODPs have to be turned in on time to receive any credit. They're automatically graded, okay? And I'm going to do a 0 tolerance here. So if you accidentally do the wrong ODP and you get a 0 out of it, it's a 0, okay? There's a few dozen ODPs. 1 low grade, 2 low grades is not going to change anything in the final reckoning. But make sure that you do the ODPs on time. Programming assignments, I will give you credit if you turn them in late, but it's a huge deduction. Okay, so don't think of this as extended time. Because 25 points if it's a few minutes late. Okay, and if you turn it in, if it's due Friday morning at 8 and you turn it in Friday at 8:30, you're down to a 75%. If you turn it in Saturday after 8, you're down to a 50% max. If you don't turn it in by Sunday morning at 8, it's a 0. Okay, so this is really just a final sort of safety net. Something happened and I never turned it in before it was due, and then my alarm clock got turned off by my cat and I didn't get up in time to turn it in. Okay, you can still turn it in and get 75% out of 100. So it's really just kind of a safety, not a I'll do it on the weekend and take a 50% deduction. Okay, assignments are submitted through GitLab again. So same as last time, right? The day that you start an assignment, which is hopefully the day that you get the assignment, make a Git repository, make a README, push it all in there, add me as a reporter. Okay? And if you do that like the first few days, I'm okay, especially in the beginning, with your sending me an email saying, hey, can you make sure that you can see my repo? I'm not going to do it the week that it's due. But if you do it like the first week, I'm okay with that. And then, as you're writing your code, every time you get to a place where you made some progress, git push origin master. And bang, it's over there, right? and you plan to make some changes Friday morning, and your cat turns off the alarm clock and you sleep in, well, I've still got the code from the last time you pushed it in there, right? And I can grade it, and you don't lose 25 points. And maybe you forgot to, add one feature and it cost you a few points, but keep pushing things over to the repository, right? Or, you clobber your code, you do a gcc-o super important program.c, and it clobbers it, right? You've got your code on GitLab, and you can pull back the last version you had and continue from there. So try to make Git like part of your whole coding routine, okay? It will definitely pay off sooner or later. Programming style is important. Make sure you have a programming style. Indent in some reasonable way. Put comments in. Use white space in between, functions and so on and so forth. I'm not going to dictate what your coding style should be, but you want a coding style. If everything's left justified, you're going to lose points. Put comments on your code. Put comments on your functions. Put a comment block in the beginning that has your name, date, class, description of the program, etc., etc. All right. Any questions on all of that stuff? So if we develop code in class, I'll post it on the server. There's a link to the shared code area. Videos are being recorded. There's a 222 channel on YouTube. There's a link to it here under lecture videos. Again, watching those is not a substitute for coming to class because you can't ask questions for the video. Yeah?
Is it okay to watch videos from previous terms?
Definitely. Yeah. Yeah, there's a different playlist for each class and each year, so help yourself. All right, resources. So the how-to cheat sheet from 224. This tells you things like how to log into the server, okay, which is different from the CTEC server. It tells you how to set up Git and how to push things over to GitLab. So if you're not familiar with these things or if you've forgotten them, either use that or send me an email or come by and see me, and we'll get that squared away quickly. But that's just sort of a few pages of basic Linux commands, how do you compile, stuff like that. A link to that additional C-book that I've written that I really wrote with this course in mind, 222, okay? This is really supposed to be the bridge between sort of preliminary C programming and more advanced C programming. So it gets into things like pointers and memory allocation and stateful programming and some of the things that you might need to do in your assignments here. So that's an available reference. It has exercises at the end of each section. If you want practice problems, feel free to have a look at that. I'm going to want makefiles with your programming assignments, so there's a short video link on how to do makefiles. If you're rusty on that from 224, if you haven't done it before, again, take a look at that and or talk to me. We'll come back to one-day programs in a minute. Quizzes. So a series of online quizzes. The first one is due Wednesday. Everybody should be able to do this one at this point. So let's take a look at the quiz. It has one question, so I'll let you ponder that. But it's due Wednesday morning, okay? This is just a hello world. So it's to make sure you have Canvas access, you know how to get to the quizzes, you know how to take the quizzes and say submit quiz, and it's just sort of a hello world thing. So, so please do that one on time. And then the other quizzes are more quizzy. So starting with the GDB quiz, which we'll probably spend some class time doing as a group. But this will give you some exercise using the debugger to explore memory and stuff. So the first quiz is due at the end of the month, and then the others are February and March. So we got some time on those. Programming assignment 1 is posted. We will start talking about that tomorrow probably, but you can eyeball it. Service learning projects. So if you did not take 224 with me, you'll want to read this first entry, SLP proposal, for those who haven't started an SLP in some other class. SLP is a service learning project. It's a generally year-long project of your own choosing to let you work on something outside of your regular classroom subjects. So if you haven't already started one of these, what you'll want to do is make a proposal, submit that to me, and then March 2nd, your final upload is due, and that's a one-page poster, which gets printed, and given to you, and then March 10th, the last Tuesday of the quarter, are the SLP presentations. That's Tuesday afternoon from 3 to 5, and I expect everybody to be there. If there's some reason why you can't be there, you need to let me know in writing by email by this noon this Friday. Okay, otherwise I'll assume you're going to be there. So we'll talk more about SLPs as we get closer to that, but if you were in 224, it's the same drill as before. One midterm, February 7th, final exam is either Monday or Wednesday, depending on which section. And again, you can switch sections. All right, ODPs. So ODPs are one-day programs. They are not just busy work. It's not just a way to give you a grade, okay? The purpose of the one-day programs is to help you self-assess your understanding of whatever it is we're doing. So we'll talk about, organizing a linked list with an array, and then you'll have an ODP that uses that concept to write a function that does something related to a linked list in an array. So these are usually short programs. They're typically, less than 10 lines of code, but they stress a particular concept. You write the code, you link it in, and there's a system you can use on the server to automatically have it graded. And it'll grade it for you, and if you don't get 100%, you can change your code and resubmit it, and you can keep doing this as long as the assignment is open. They usually open at 8:05 in the morning, and they close 8 o'clock the next morning. So you have one day to do these. And my suggestion is, when it opens at 8 in the morning, take a look at it before class so that you can ask questions about it during class. And we'll spend a few minutes in class going through the ODP and looking at it, but if you've looked at it ahead of time, and then as we're going through it, you can say, I don't understand such and such, right? And we can clear that up right away. What you don't want to do is ignore the ODP until 11 o'clock at night, and then look at it and try to write it, and you get 0 out of 10. And now it's the middle of the night, and it's due at 8 in the morning, and I'm probably not going to be responding to emails until the next day, and so you're kind of stuck. All right, so look at the ODPs as soon as you can, preferably before class, and then we'll go over them in class, and you can ask questions then, and then write it up and submit it and get it graded, get 100%, and you're good to go for the next day. So let's do 201 as a class. This is another hello world, okay? This does not have anything to do with anything in data structures. This is just a warm-up to using the automated assessment system. But this is what most of these things will be like. You'll be writing a function in C. So in this case, the assignment is write a function called sum, which takes 2 integer arguments and returns their sum. Okay, so how do we do this? Hop onto the server. Okay, so I'm going to write this thing called 201.c. And there's my sum function. It's not terribly complex. Takes 2 integer arguments, adds them together, returns that. Okay, I can take this and I can submit it to the automatic assessment system. And maybe I'll get 10 out of 10, maybe I won't. If I don't get 10 out of 10, I gotta figure out what's wrong with this, right? But even if I do get 10 out of 10, it's possible I got a problem with this, because it's not a perfect assessment system. What you really want to do is suppose that you were going to turn this in to me for a grade. And you don't get to turn it in multiple times, right? You're just going to send this to me and I'm going to grade it. You would want to make sure it works first, right, before you actually submit it. So write yourself some test code. All right, so this is what we can think of as a test bed. It's a program that exercises this sum function. And in this case, I'm just calling sum, I'm passing it 22 and 45. I get the answer back, then I'm just printing out that answer with a %d. And I'll want to prototype my function, because C likes when you prototype things. Now this is a pretty simple function. It's a one-line function, but you know, some of these might be more complex. So you might add some comments. All right, so there's some comments. You're not going to get marked off if you don't have comments because it's created by an automated system, right? But if this is something fairly complex, right, comment your code. Right? Commenting will help you if you have to go back in and figure out what's wrong with your code, right? It'll help you know what's going on. Okay, so this is called 201.c. So I compile it into an executable called 201. I'll run it. It tells me sum return 67. Okay, I feel pretty good about my function right now. I think it probably works. So what am I going to do? Well, let's see. I'm just going to make a new file called sum.c. And I'm going to take out my main program. And sum.c is just going to have my sum function. Okay, so it tells you there's a test bed, there's a main program being supplied called /temp/main.o. Right? So you're writing the function sum, I'm giving you a main program, you're going to link them together, and you're going to take that executable and submit it for assessment. Okay, so first you do your manual testing, write your own main program, etc., etc. And then when you're ready to test it automatically, compile it like this. Okay, so gcc-o we can call it whatever we want. We'll call it ODP 201 /temp/main.o and sum.c. Okay, so what am I doing? I'm saying compile sum.c, that's my function, link it with /temp/main.o, that's the main program that's been supplied to you, call the output file ODP 201. You can call it whatever you want. You can call sum.c whatever you want, but pick reasonable names and don't just keep reusing the same name from one ODP to the next, because eventually you'll get confused and that wastes a lot of time. So my executable program is called ODP 201. Okay, so to assess it, say assess executable program, source program. So assess ODP 201 sum.c. And now we're running the assessment system, okay? Double check this thing under the between the two lines of asterisks. You are about to assess your code for ODP 201 function to receive two integers and return their sum. Yeah, that's the right ODP. If it's something different, if this says ODP 202, stop what you're doing. Just X out of here, because you're not using the right ODP. Okay, but if you do this before 8 o'clock tomorrow morning, it should say ODP 201. We're good to go. We're going to use the G option. G says submit your code for grading, and it ran 5 tests. I got 10 out of 10 on each. Perfect. Okay, I can do X or I can do Control D to leave here, and we're all set. Now suppose I go double crazy and I make these things doubles instead of ints, right? So I recompile, I reassess, I say grade. Well, I got 0 out of 10 on 4 of my tests. I got 10 out of 10 on 1. So I got 10 out of 50 for this. Okay? You really want to get 10 out of 10 on every test. If you're not getting 10 out of 10, if you're getting 8 out of 10 on 1, there's something wrong. Okay? And you want to try to figure out what that is. How do you figure that out? Well, you really got to go back to your code and you got to look at the assignment. right? I can't just run my function because this function is made to be run through the assessment system, right? The fact that it gave a seg fault is not a problem per se because you're not supposed to run it from the command line. It's a test bed that's supposed to be automatically assessed. So you go back into your code and you look at the assignment and you read it carefully and it's like, oh, 2 integer arguments. Okay, I use doubles instead. All right, so you change it and you reassess. Okay, if everything goes right, it takes 5 minutes. If there's something silly that's going on like this, it can take longer. If there's something fundamental going on, like I don't know how to return a value from a function, it can take you 3 or 4 hours. Okay, it's time well spent. Because if you're having trouble returning a value from a function, right, that's something you really want to figure out. And whatever it takes, you want to learn what you're missing that day, right? So that the next day you can build on top of that. So that's the nature of the ODPs. All right, does that make sense? So that's ODP 201. It's open. It closes tomorrow morning at 8. Go ahead and do that. If you can't get into the Linux server, if you don't know how to use Assess or something, come and talk to me as soon as possible. And the next ODP will open Wednesday morning, and then there'll be one Thursday, and there'll be one Friday. All right, any questions on any of that? All right, let's talk about data structures. So, data is the thing that we manipulate with our code, right? We write programs, there are instructions that say, add these things together, increment this, compare this to that, and so on. The things that we're operating on, that we're comparing to, and so on, that's data. Okay, it's the object of the verb. And data is really just ones and zeros stored in the memory of the computer, right? And we can organize it and interpret it different ways. We can take a set of ones and zeros and treat it as a character using an ASCII code, or we can treat it as an integer using weighted positional notation, or a floating point using IEEE 754. There's different ways to interpret it, but fundamentally, data is just a bunch of ones and zeros stored in memory. And so if we sort of picture the memory of a computer, and memory tends to be byte oriented still, so this is 8 bits, and this is memory location 0, 1, 2, 3, and so on. And let's say we want to store somebody's name. So we want to store the name Jane. So we might store a J and an A and an N and an E. Or we might have stored these letters down here. Or we might have stored a J, and then 2 spots later an A, and 2 spots later an N, and 2 spots later an E. Or maybe we wake up on backwards day, and we store it like that. Now these are all valid ways of storing 4 characters in memory, and as long as we know where it's stored in memory and how it's organized, we can retrieve the name. If we know it starts at location 11 and it's stored backwards, right, we can pull out J-A-N-E. If we know it's stored starting at location 3 and we're using 16 bits per character, it's J-A-N-E. But there's a lot of different ways we can choose to organize this information. And that's a lot of what we're going to be studying this quarter. Different ways to store information and why we might store it one way versus another. And we're not thinking of the level of, say, a database. Okay, we're much lower level than that. We're really thinking in terms of storing ones and zeros into memory locations. And in C, usually we just store the letters of a name in sequential memory locations. And where it starts, who knows, right? But it starts somewhere and then sequentially. And we do this peculiar thing where we put this \0, this null terminator at the end, if we're working in C. But that's just a convention. So suppose we want to store somebody's name and their ID and what class they're taking. And so we have Bob with an ID of 23, and they're taking CSE 219. And we've got Mary with an ID of 19, and they're taking CSE 222. And we've got Jim with an ID of 24, and they're also taking CSE 222, and so on. So this is a bunch of strings, right? Collections of characters. These, let's just say they're integers, so they won't go over 2 billion, but they're just integers, and these are collections of strings also. So a series of bits represent each of the letters in this name, represent this value 23, and represent each of the letters in this class. And we can toss those bits anywhere we want in memory. As long as we know where they are and how they're organized, we can retrieve this information. But we probably don't want to just throw them into random locations in memory. Ideally, we have two things happening. One, if we find the name Bob, we can find Bob's ID somehow from knowing where their name is, and we can also find what class they're in somehow from knowing where their ID is and where their name is. We want some sort of relationship between these three pieces of data, some sort of structure. And two, since we might have a list of 1,000 students, we'd like to be able to easily find, the third student, Jim, without having to have a variable called, Jim's location, and a variable called Mary's location, and a variable called Bob's location. We'd like to have some sort of organization to where each of these records is stored. And so this is where we get into the concept of an array. And an array is a first example of a data structure. It's a collection of data that's not just randomly stored at different locations in memory. There's some sort of relationship among the different pieces of data. So if we wanted to store these IDs in an array, we might have an array called IDs. And maybe we set it up to be big enough to hold 1,000 IDs. And then somewhere in memory, so here's our mem. Somewhere in memory, we have the beginning of our array, IDs bracket 0. And we would store a 23 there. Now, integers typically take 4 bytes. Remember, this memory is 1 byte wide. So typically, 4 of these bytes would correspond to 1 integer. So IDs bracket 0 would be right here. IDs bracket 1 would be right here, and this might be the ID of the second student. And IDs bracket 2 might be right here, and this would be the ID of the third student. So it would have a lot of zeros in here, but if the numbers were bigger than 255, right, we'd have interesting values in here. So that's a simple array of integers, right? And it has the advantage that if we want to know the ID of the 15th student, we can simply take the address of this, add 15 times 4, in this case, because each entry takes 4 bytes, and that'll give us the address where the 15th student's ID is. And we can do things like parallel arrays. where we could have a series of names. And names bracket 0 will be the name corresponding to IDs bracket 0 corresponding to classes bracket 0. And now if we want to know the name, ID, and class of the 15th student, we look at names bracket 15, IDs bracket 15, and classes bracket 15. Right, so parallel arrays, we've done these in 224, you've done them in 121. That's one way to organize this set of data so that it all goes together. We're respecting the structure that this ID is not just a random ID, it goes with this name and it goes with this class. So here's something to think about. How do we store these three names in memory?
NRF strings.
Yeah, there's a few possibilities. Here's one way. We store Bob, and then we store Jane, and then we store Jim. And that's very efficient memory-wise. We're not really wasting any space. I got that null terminator there to tell us where the name ends. And now if we want to know the third name, we start at the beginning. We find the end of the first one. We find the end of the second one. This is where the third name begins. And it goes until we get to that end. It's efficient space-wise, but it's slow. If we wanted the millionth name, we'd have to go through a million names looking for a million of these null terminators to get to that millionth name. So here's what we do. We store these things in memory. And we make an array and we say, where does each name begin? Bob begins at 100, Jane begins at 104, Jim begins at 109. And now if we want to know where the millionth name is, we just take the millionth element of this array. That's going to tell us where the millionth name begins. And how do we find the millionth entry in this array? Well, take the address of the first thing, add 1,000,000 times 4. That's the address of the millionth thing. So this is really what we call a car star star. It's an array where each thing in here is a car star, a pointer to a character. What we also call a string or a character array. And this is what argv is. Okay, here's the nice thing about this. If we wanted our names to be in a different order, all I got to do is that. Now if I ask for the first name, it's Bob. If I ask for the second name, it's Jim. If I ask for the third name, it's Jane. And I didn't have to move these things around. I just changed those pointers. Okay, that's where we're going to start from tomorrow. That's going to lead us to something called a linked list. And it's going to be a way to manipulate big arrays of information without having to actually move things around in memory. We're just going to change the references to them. All right, so we'll start from there tomorrow.